Hey Cubs, welcome back. So this video is going to go over sample problems C, D, and E found on page 258 and 259 of your textbook. So let's start with sample problem C. It says the reaction of zinc with aqueous hydrochloric acid produces a solution of zinc chloride and hydrogen gas. So we want to start by writing down the word formula. We have zinc plus hydrochloric acid produces. So anytime you hear the word like produces or will yield or reacts to form, that means a reaction arrow. A solution of zinc chloride and hydrogen gas. So now that we have our word formula, we want to convert this into the chemical formula. So zinc is just Zn because it's not one of the 7 diatomic molecules. Hydrochloric acid is HCl to produce zinc chloride. So zinc has a 2+ charge and chlorine has a 1- charge. So when we do our switcheroo, we end up with ZnCl2 plus hydrogen gas. Now hydrogen is one of the 7 diatomic molecules, so we need to make sure that we include the subscript 2 when we're talking about hydrogen gas there. So now we have our chemical formula. Now we need to go about balancing the equation. So we have zinc present, hydrogen present, and chlorine present. Zinc, hydrogen, and chlorine. We have 1 zinc on the left-hand side. We have 1 zinc on the right-hand side. Right now we have 2 chlorines on the right-hand side. So we need to end up with 2 chlorines on the right-hand side. Now we can't add a subscript in here because then we would have an incorrect chemical formula. We need to leave this chemical formula as it is, but we can change the coefficient here. So if we place a 2 in front of the HCl, we now have 2 chlorines on the left-hand side, and we still have the 2 chlorines on the right-hand side. Hydrogen, we have 2 hydrogens on the left-hand side and 2 hydrogens on the product side. So when these values are all equal to each other, we then have a balanced chemical equation. So 1 mole of zinc plus 2 moles of hydrochloric acid react to produce 1 mole of zinc chloride and 1 mole of hydrogen gas. Box or circle your answer. So that's for sample problem C. Let's take a look now at sample problem D. Sample problem D says sodium solid aluminum carbide, Al4C3, reacts with water to produce methane gas and solid aluminum hydroxide. So let's start by writing down our word equation. We have aluminum carbide reacts with water to produce. Remember, when you see to produce or reacts to form, that's the reaction arrow. Methane gas and aluminum hydroxide. So aluminum carbide, we're told, now that we have our word formula, let's go to the chemical formula. Aluminum carbide, we're told, is Al4C3. Al4C3 plus water, it's H2O, reacts to produce methane gas, CH4, and aluminum hydroxide. So to get aluminum hydroxide, we have aluminum with a 3+ charge, hydroxide with the -1 charge. So when we do our switcheroo, we have Al1, OH3. Clean it up, we can drop the 1. But we need to keep the parentheses because outside of the parentheses we have the subscript 3. So we have AlOH3. Now we can go about balancing this equation. We have aluminum, carbon, hydrogen, and oxygen. Aluminum, carbon, hydrogen, and oxygen. So if we take a look, we have 4 aluminums on the left-hand side. So we need to get 4 aluminums on the right-hand side. Now we can't add a subscript, we can only adjust the coefficient. So if we put a 4 here, we end up with 4 aluminums. Now carbon, we have 3 carbons on this side. So if we place a 3 here, we have 3 carbons on the product side. Now we have hydrogen and oxygen to deal with. So with the oxygen, we have 4 units of aluminum hydroxide, and each one aluminum hydroxide has 3 oxygens. So 3 times 4 gives us 12 oxygens. So now we need to put a 12 in front of our water to give us 12 oxygens on the left-hand side. Now if we take a look at hydrogen here, we have 3 times 4, so that's going to be 12 hydrogens from methane, and 3 times 4, because this 3 distributes, 3 times 4, we have another 12 hydrogens from our 4 aluminum hydroxides, giving us a total of 24 hydrogens. On the reactant side, we have 12 times 2, we have 24 hydrogens as well. So then our balanced chemical equation for sample problem D is going to give us Al4C3 plus 12 moles of water will react to produce 3 moles of methane gas and 4 moles of aluminum hydroxide. Box or circle that answer. Let's do one more practice problem found on page 259, sample problem E. We have aluminum sulfate and calcium hydroxide used in water purification. So when we add these to water, they react to produce 2 insoluble products, aluminum hydroxide and calcium sulfate. So we have aluminum sulfate plus calcium hydroxide react to produce aluminum hydroxide and calcium sulfate. So now that we have our word equation, we can move on to our formula. So aluminum has a 3 plus charge, sulfate, SO4, 2 minus. So when we do our switcheroo, we end up with Al2, SO4, 3. Calcium hydroxide, calcium has a 2 plus charge, hydroxide has a 1 minus charge. So when we do our switcheroo, we end up with calcium hydroxide, CaOH2. Notice we keep the parentheses here because the subscript outside of the parentheses is a 2. Aluminum has a 3 plus charge. Hydroxide has that -1 or 1 minus charge. Do our switcheroo, we end up with AlOH3. And then calcium has a 2 plus charge. Sulfate has a 2 minus charge. So once we do the switcheroo and clean it up, those 2's will cancel out and we end up with CaSO4. Now we don't have parentheses around this sulfate here because the subscript outside the parentheses would be a 1, negating the need for the parentheses here. So now that we have our chemical formula equation, let's go ahead and balance this equation. We have aluminum, we have sulfate, we have calcium, and we have hydroxide. Aluminum, sulfate, calcium, and hydroxide. Now you might notice I kept the polyatomic sulfate and hydroxide together in this case. So I did because they appear on both sides of the equation as a polyatomic, both sulfate and hydroxide. Keeping them together can sometimes make it a little bit easier instead of breaking up and adding up the oxygens here and the oxygens here. I like to keep the polyatomics together when I can. So let's take a look at aluminum. We have 2 aluminums on the reactant side, and we have just 1 aluminum on the product side. Remember, we can't add a subscript. Once we have the proper chemical formula, that stays the same. But what we can change is the coefficient right here. We place a 2 in front of aluminum hydroxide. That gives us 2 aluminums on both sides now. Now if we take a look at calcium, we have 1 calcium, 1 calcium. Let's take a look at our sulfates. So we have 3 units of sulfate on this side, and we have just 1 unit of sulfate on the right side. So if we change the coefficient to a 3, this 3 distributes to the sulfate and the calcium, so now we have 3 sulfates on both the reactant side and the product side. When we change that 3 for the sulfate, it also changed our number of calcium here too. So we have 3 calciums on the product side. We need to have 3 calciums on the reactant side. Remember, we want to have the same number and type of atom on both sides of the reaction arrow. So we need to change the coefficient here to a 3. Now we have 3 calciums, 3 calciums. Calcium's good. Let's take a look at hydroxide. On the left-hand side, on the reactant side, we have 3 times 2. We have 6 hydroxides because this 3 distributes. So we have 6 hydroxides on the reactant side, and we have 2 times 3 because this 2 distributes. We have 6 hydroxides on the product side. So when we write out our balanced chemical equation, we have 1 mole of aluminum sulfate reacts with 3 moles of calcium hydroxide to produce 2 moles of aluminum hydroxide and 3 moles of calcium sulfate. And then box or circle your answer. Please let me know if you have any questions. We've got that discussion board up and running. If you guys do have questions there, you can also reach out to me by email. Have a great day, Cubs.